Previously, we were just looking at how our resting metabolic rate depends on both our energy intake and our energy expenditure. So, what we see is actually metabolic adaptation or adaptive thermogenesis. And this is defined as a decrease in resting metabolic rate with weight loss beyond what can be predicted from the loss of body weight and the corresponding changes in fat and lean mass. So this is a change in metabolic rate leading to change either higher or lower heat production. So some reasons that metabolic adaptation can happen are environmental influences, such as cold acclimation or a response to drugs or hormones, and potentially diet composition. So here we have some data from the Biggest Loser study. And yes, this was with the TV show The Biggest Loser. But we see we have data from the end of a 30-week competition. We have follow-up at 6 years, and then we have various p-values. So first, let's look at our RQ. The RQ for the individuals at baseline was around 0.77, so using fats and some carbohydrates. And we see that baseline to 30 weeks, no significant difference. But something interesting happens at a 6-year follow-up. The RQ increases. We're burning more carbohydrates at 6 years. So more CHO at 6 years. And this one is significant. It's significant compared to baseline and significant compared to 30 weeks. Okay, well, let's look at our RMR measured and predicted. At baseline, the RMR measured is around 2600. The RMR predicted, also around 2600. But we see that there's still some give in there. So 2607 minus 2577 is 0. 10 is 3. 0, 0. By about 30 calories. If we look at the end of the competition, we see that their resting metabolic rate has dropped, and it is significant. If we look at 6-year follow-up, though, their resting metabolic rate has dropped even more. And it's significant compared to baseline, but not significantly different compared to 6 years, this at the end of the competition. So let's keep these notes. So at 6 years, they are using more CHO, and their resting metabolic rate is decreased. If we look at the difference between RMR predicted and measured, we see at first it's pretty accurate. It's around 30 kcals. But we see that it becomes much less accurate. Our predictions are not matching up with the measured. At the end of 30 weeks, they're different by almost 300 calories, and by the end of 6 years, they're different by almost 500 calories. Well, there's a couple of things that may explain this. Maybe it's the physical activity. So at the end of the competition, they had more than doubled, or about doubled, their physical activity. And this was maintained through the 6-year follow-up. If we look at their weight, we see that their weight decreased, but it increased back up to almost baseline levels. And in fact, it is still significantly different than baseline, but it's not nearly as significant as it was. Well, if we look at percent body fat, we see that initially percent body fat drops. But at 6-year follow-up, it's almost back to baseline. So here we see it's not significant. So their RMR has dropped. Percent body fat has regained. Let's look at their fat-free mass. So they actually decreased their fat-free mass at the end of the competition, and they increased their fat-free mass at a 6-year follow-up. If we look at the p-value of baseline versus 6 years, it's significantly different, but it is much closer. Let's look at fat mass. That also decreases, but it returns back up towards normal at the end of 6 years. See, it's only barely significant. So we're seeing that we see a large loss in fat-free mass at the end of the competition. But we actually see a gain in fat-free mass at 6 years. What we don't see, though, is that this metabolic adaptation tends to get worse. So our predictions aren't adding up to the measurement. So something about the loss of fat-free mass and the calorie restriction has depressed the resting metabolic rate. So this study was done with exercise. What about if someone has undergone bariatric surgery? So here we have baseline, 6 months post-surgery, 24 months post-surgery, and 24 months post-surgery, so 2 years. If we look here, we see that the resting metabolic rate decreases at 6 months post-surgery and increases a little bit. If we look at the residual, which is this is the error in this, we see that it's very low initially, it increases and goes back down. So it looks like resting metabolic rate is decreasing and then increasing. But if we look at the weight loss, we see they keep losing weight, so it decreases and decreases. Percent body fat has decreased. Body fat in kilograms has decreased. And fat-free mass has also decreased. So it could be that the lack of fat-free mass is making this resting metabolic rate lower than it was at baseline, along with a smaller body, which means a lower resting metabolic rate. So we can also look at some other differences in resting metabolic rate between weight loss types. So Fothergill, this is the Biggest Loser study we looked at, and they used extreme exercise. So they decreased their resting metabolic rate with weight loss. It was around 1900 kcals per day at 6 years. Their total energy expenditure had increased, though, to 3,400. Their fat-free mass was greater at 6 years. The bariatric surgery was similar I found another study. This isn't the exact one we saw, but it's with bariatric surgery. At 6 years was similar to extreme exercise. Total energy expenditure, though, lower with bariatric surgery. Fat-free mass, lower with bariatric surgery. So with extreme exercise, we saw around 12% weight loss. We saw adiponectin improved by 12%, triglycerides improved with 12% weight loss, triglycerides improved with 12% weight loss, and leptin improved. With moderate exercise and an 11% weight loss, we see similar values for adiponectin, similar values for triglycerides, and similar values for weight loss. So it's not necessarily about the type of exercise, it's about the amount of weight lost. Similarly, go way back, we see that extreme exercise and bariatric surgery result in similar decreases, although bariatric surgery, it looks like decreases resting metabolic rate a little bit more, and that's probably because we don't see the same increase in energy expenditure, and we see lower fat-free mass at 6 years.